is 2x, quantity x minus 1, quantity x plus 2. So I have that typed into y1. And I know I'm going to need to find some zeros, so I went ahead and plugged in a 0 into y2. So notice this function that we're looking at is the derivative function. So this is the graph of f prime of x. So it says we want to use the derivative graph to find out information about the original function f of x. So the first thing it asks me is about increasing and decreasing intervals. So we know that f of x is increasing if f prime of x is positive. So this is my graph. I need to know where this is positive. So I see from here to here, and then from here and above is where it's positive. So I need to find those exact values. So I'm going to do that intersection feature. So make sure you have the 0 typed into y2 in order to do that intersection. So if I do second trace, I'm going to do intersect, press enter, enter, and then just for the guess, I want to find this one first. And I know this is -2 because the function, notice, it was factored, so we can find those zeros right away. But if it wasn't factored nicely, this is how you would find it. So that's -2. This value right here, you can do the intersection feature again, you'll see is exactly 0. And then this last one here, that value is x equals 1. And I could tell by the equation because it's factored. But if you want to do it with the calculator, that's the way you would do it. Okay, so first piece, when is f of x increasing? Well, I know f of x increases when f prime, which is this graph, is positive. So this graph is positive or above the x-axis from -2 to 0, and then also from 1 to infinity. And then f of x decreases when f prime is negative. So where is this graph below the x-axis? That would be from -infinity to -2. And then this little piece from 0 to 1. And then the next question asks about just the x values of the local max and the local min on the original. Again, this is f prime. I'm not looking for the local maxes and mins of this graph. I want to know what's happening on the original function f of x. So I know that local maxes and mins can only occur if f prime is equal to 0. In this case, these are my 3 possibilities right here, -2, 0, or 1. Now let's see what happens at -2. Notice that -2, the sign of the derivative goes from negative below the x-axis to positive above the x-axis. So that means the original graph is decreasing, then increasing, so that would be a local min. So at x equals -2, the original graph has a local min. Now at x equals 0, f prime goes from positive to negative. So that means f goes from increasing to decreasing. So x equals 0 would be a place where you would have a local max. And then at x equals 1, the derivative goes from negative to positive. So that means the original goes from decreasing to increasing. So that's another local min. So again, the idea is we're using f prime of x here to find out information about the original f of x.